In this video, we're going to be talking about how to interpret pie charts. So what you see here is a pie chart, and looking at the question context, the pie chart shows you the proportion of greenhouse gas emissions in the world that each economic sector contributes to. So if you're not sure what economic sector means, basically if you look at the pie chart, it's already stated there. So industry could be things like manufacturing industry. That's one sector. Transport, buildings, agriculture, electricity. All these are different sectors of the economy. It's given to you, nothing for you to remember. Just look at the graph and answer the question. Okay, another thing to take note of about the pie chart is this. You would realize that the question context actually is just a rephrase of the title of the graph. So global greenhouse gas emissions just means greenhouse gas emissions in the world. It's just a different way of phrasing things so that you can understand it a bit better. So if you didn't understand what the title was, go back to the question context. You should hopefully be able to understand it slightly better. So a pie chart, the purpose of a pie chart is actually to show you the proportion, this word here, of each data set or each category of data. Why is it proportion? It's because you look at the percentages here. Everything adds up to 100%. You're just trying to figure out what proportion of the 100% that particular sector takes up. Okay, so proportion and pie chart goes together. If you're asked to represent certain data sets as a pie chart, this data set tends to be proportion based or percentage based. So typically for a pie chart, they may ask you this question: describe the distribution of whatever data sets you see. And if you're asked a question of distribution, basically you should be looking out for things like the highest and the lowest data points. So which sector contributes the most, which sector contributes the least. And in this case, you will see electricity and heat production the most. I want to quote the percentage so that I'm actually making use of data in the figure to support my answer. Next point I want to give, buildings contribute the least. Again, quote the data, 6%. So this 2 points would already get you 2 marks. Where do you find a third mark if this, let's say, is a 3-mark question? You actually have a lot of choice as to where to find a third mark. You can talk about the second highest, second lowest, or right in the middle. My recommendation tends to be second highest. Okay, agriculture, forestry, and other land use, quote data, or you can talk about second lowest here. Other energy, 10%. So the third point is completely up to you. Make your choice, whatever it is, quote data. Moving on to the second type of more complicated pie charts. So in this case, you would already see this in your Sec 1 textbook about water, and it might appear again in different situations. How water is distributed in the world. Okay, it just means this, global distribution of water. So this is, both of it is pretty easily understood. Nothing much to explain. The complex thing comes from these two pie charts. How are they related? If you look at the original pie chart here, oceans, 97%, freshwater, 3%. Let's call this pie chart 1. You look at pie chart 2 here. Okay, this is 2. Groundwater, lakes and rivers, glaciers, all these add up to 100%. So each pie chart individually adds up to 100%. The key is, how are they related? If you look at the first graph here, freshwater only constitutes 3%. And my second pie chart is just an extension of this very small segment of freshwater. So this one is only about freshwater. If I zoomed out, this is the second pie chart I would see. So the reason why there is an extension of a pie chart here, there's a zoomed out version, is because if we were to try to combine both pie charts together, each sector in the original pie chart here will be very, very small. It will be very, very difficult for you to see. So it's actually easier if there's a zoom out version of it and you get to see the pie chart with greater clarity. So one kind of question that may appear, other than distribution, is that they will ask you, glaciers. So out of the whole world's water, all the water on Earth, how many percent are stored as glaciers? Okay, the answer cannot be 70%, because 70% plus 97% is already more than 100%. Okay, so it cannot be that the Earth has 97% oceans, 70% glaciers, and then still 3% fresh water. The numbers don't add up. Okay, so how you calculate this? How many percent are glacial water compared to the entire world? You have to take fresh water, 3%. Because remember, glaciers come from fresh water. They are a part of fresh water. 3%, 70% out of the 3% are glaciers. Okay, not 70% of the first 100%, 70% of this very small portion only. So mathematically, I'm just going to take 3% times 70%, so doing a bit of math here, 0.03 times 0.7, that would get me 0.021, and that would get me 2.1%. So glaciers only constitute 2.1% of the entire world's water. Okay, but glaciers are 70% of fresh water. So notice the difference in wording. 70% of fresh water, but 2.1% of the entire Earth's water. Okay, picking another example, if you look at lakes and rivers, let me just use another color here. If the question asks you, lakes and rivers, how many percent of water is stored in lakes and rivers compared to the entire world? What I have to do is I have to take 3% times 1% to get my answer. Similarly for groundwater, if they ask you, how many percent of water in the entire world is groundwater? I take 3% times 29%.